Today's lesson is on polynomials. Poly means many, and a polynomial is a mathematical expression with many terms. Terms are separated by pluses and minuses. So this polynomial here has 1, 2, 3, 4 terms. If an expression only has one term, it's called a monomial. If it has two, it's called a binomial. Remember, bi means two, like bicycle with two wheels. And a trinomial, tri means three, like a tricycle with three wheels. And a trinomial has 1, 2, 3 terms. Again, they're separated by pluses and minuses. So this is a monomial, this is a binomial with 2 terms, and this is a trinomial with 3 terms. But after you have more than 3 terms, it becomes a polynomial. We just say many, many terms. Sometimes you'll hear binomials and trinomials being referred to as polynomials. Just means it's a polynomial in general, but if you want to be more specific, you'd call a 2-termed polynomial a binomial and a 3-termed polynomial a trinomial. And we want to be careful. If you see a rational expression like this with a big division sign here, a division line, you might think this has 1, 2, 3, 4 terms. It might be a polynomial. But because of the order of operations, this whole thing is considered a monomial, just one term. So let's now add and subtract polynomials. First of all, it's important to know that if you have a plus sign in front of parentheses, you can just remove the parentheses. We don't need these parentheses if there's a plus sign in front of them. I won't bother to remove it this time, but just keep that in mind. So when we want to add up these terms, the only things we can add are like terms. Like terms are terms that look alike. Think of them like apples or oranges or chairs. You can't add an apple and an orange. You can only add apples or oranges or chairs. So, for instance, 3x cubed is a lot like 2x cubed. Those are identical except for the number. So we have 3 apples plus 2 apples. And that makes 5 apples, 5x cubed. Let's look for another like term here. We have a 7x squared. Are there any other x squareds? No, there aren't. So I'm just going to copy that down. What about x's? Are there here minus 15x? Are there any other x's? Yes, there's a minus 8x. So that's minus 23x. And the minus 36 can be combined with the 3. Minus 36 plus 3 is minus 33. So what we did was just add the like terms. We just combined the like terms to simplify this. Let's look at this next one. We have an x squared. Let's look for any other x squareds along here. Here's one, and that's it. So we have a 4x squared plus a 2x squared. That's 6x squared. And xy. Let's look for any other xy's. We have minus 7xy here, minus 4xy here. So that's minus 11xy. And we'll cross out the ones that we've accounted for. We have a y squared here. So we have 5y squared here, and we have a 6y squared here. But be careful because you're subtracting it. 5y squared minus 6y squared. A minus in front of parentheses means that minus applies to every term in the parentheses. So we have a 5y squared minus 6y squared is minus 1y squared. We took care of that one and that one. Minus 3z squared plus 8z squared is plus 5z squared. Minus 5xz minus xz is minus 6xz. And that's how you add and subtract polynomials. What about multiplying polynomials? When you multiply, the only way you can multiply these, in this case, this is a monomial times a monomial, but the only way you can multiply these is if the bases are the same. In this case, x and x are the same, so we can multiply these. And when you multiply and the bases are the same, the base stays the same and you add your exponents. So x to the 3rd times x to the 5th is x to the 8th. Here, our bases are not the same. It doesn't matter that the exponents are the same. The bases are not the same, so we cannot multiply these. I'm just going to copy this down again without the dot in between because you don't actually need that. That's as simple as that can be. And here we're going to multiply a binomial times a trinomial. And to do this, we have to distribute the x cubed through. So we have to multiply the x cubed times all three of these terms. Then we're going to multiply the 2x and distribute that through to all three terms. So x cubed times 15x to the fourth is 15x to the seventh. Our bases are the same, the x and x are the same, so we add our exponents. Then we say x cubed times negative 3x cubed is minus 3x, and we add our exponents. 3 plus 3 is 6. We just added this exponent to this exponent. Then x cubed times 5 is 5x cubed. Now we start with the minus 2x, and we're going to multiply that by all three. Minus 30x to the fifth. That's the 2x times 15, or the minus 2x times the 15 is minus 30. And then x times x to the fourth is x to the fifth, because if x is by itself, it really has a 1 there as an exponent. They just don't write it in. Then minus 2x times minus 3x cubed is positive. A negative times a negative is a positive. 6x to the fourth. And our last term is going to be minus 10x. That's minus 2x times 5. Now we can look here to see if we see any like terms that we could add up together. We have an x to the seventh, an x to the sixth, an x to the third, 5, 4. We don't have any like terms here, so we don't have to combine anything. To neaten this up, we should write it in descending order, which just means all of our exponents start at the larger number and descend down in order. So we're going to put our 7, our 6, our 5, our 4, our 3, and we don't have a 2, but now this is all in descending order, and that's customary. That's the way you want to leave your answer. So let's do some practice. Let's first identify each of the following as a monomial, binomial, trinomial, or polynomial, and state its degree and any coefficients. So this first one is a monomial, is degree 2, and 4 is the coefficient. A coefficient is a number that sits in front of a variable and is being multiplied. So 4 is a coefficient. This is degree 2, and it's a monomial. This next one is a binomial. It's degree 3, and 5 is a coefficient. 3 is not a coefficient. It's not sitting in front of a variable. It's called a constant. This next one is a trinomial. It has 3 terms. 1, 2, 3. Remember, terms are separated by pluses or minuses. It's degree 2 because that's the highest exponent. This has degree 1 and this has degree 2, but the degree of the whole polynomial, the whole trinomial in this case, is degree 2 because 2 is the highest exponent in the group. And we have 2 as a coefficient and 3 as a coefficient. And this last one is a monomial. It's not a binomial, it's just a monomial because of this big division sign here. That's all considered one term. And it's degree 1 and 2 is a coefficient. Let's simplify the following. X times x times x times x. All these bases are the same, and what you don't see here, they're all x to the first, x to the first, x to the first, x to the first. So this is x to the fourth. We add up our exponents. When you're multiplying and your bases are the same, you add your exponents. For this next one, we have 3 bases that are the same. This is really x minus y to the first, times x minus y to the first, times x minus y to the first, times z. So this can be written as x minus y, that's that base, to the third, when we add up 1 plus 1 plus 1, times z squared, because this is z to the first times z to the first. This next one, we have no like terms to add or subtract, and we're not multiplying, so there's nothing more we can do there. It's in descending order, it's perfectly expressed. This next one, we're adding 3 terms, so we're looking for like terms. xy squared, xy squared, xy squared. So we can combine all 3 of those, just like apples. We've got 7 apples minus 3 apples plus 8 apples. So 7 minus 3 is 4. 4 plus 8 is 12. So we have 12 of these. This next one, we're adding or subtracting these 2 terms. We're not multiplying. And we do have like terms, x squared y and x squared y. We have minus 5 plus 3. Subtracting a negative is just like adding a positive. So minus 5 plus 3 is minus 2. This next one, before you start a problem, you really want to be aware of whether you're adding, subtracting, or whether you're multiplying. Here we're adding, subtracting, so all we're looking for is like terms. We've got a 3x squared minus a 2x squared, so that's 1x squared. We've got a 5x minus a 7x, that's minus 2x. We've got a minus 3 plus 17, and that's plus 14. And for this next one on the page, we're going to do the same thing. We have an x squared minus a 3x squared is minus 2x squared. We have a minus 2x minus 3x. Be careful here. That negative sign gets distributed through to every term. Minus 2x minus 3x is minus 5x. And minus 12 plus 7. We're not distributing these three through. We're not multiplying. We're just combining like terms. 12 and 7 are both constants. Those are like terms. So minus 12 plus 7, because of this minus sign here. Minus 12 plus 7 is minus 5. Here's another longer problem. Look first to see if you're multiplying or if you're adding, subtracting. We don't see any dots here. We're not multiplying. So all we're doing is looking for like terms. Now, because there are enough like terms here, I see, an x cubed, an x cubed, and an x cubed. I'm going to go ahead before I start adding and subtracting these like terms to distribute this negative sign through. It'll just make things easier. So I'm going to rewrite this as 4x cubed plus 2x squared minus x minus 3 minus x cubed plus x squared, because this negative sign changes every sign that's in the parentheses, minus 3x minus 4 minus 2x cubed. This plus sign doesn't change the sign of anything in the parentheses, so you don't need these parentheses. But we do have a minus 2x cubed here, plus 3x squared, plus 5x, plus 6. I just did that, so now we don't have any parentheses. We don't have to worry about distributing a negative sign through the parentheses. So now let's look for like terms. 4x cubed minus x cubed minus 2x cubed. That's x cubed. 2x squared plus x squared is 3x squared, plus 3x squared is 6x squared, minus x minus 3x is minus 4x, plus 5x is x. Minus 3 minus 4 is minus 7, plus 6 is minus 1. Okay, so I'll erase that just to clear the board. For this next problem, we're multiplying, and our bases are the same. So we can say x to the 5th times x to the 7th is x to the 12th. We add our exponents. This next one is our bases are the same, so we keep our base, and we're going to add our exponents. 9n plus 3n is just like 9 apples plus 3 apples is 12 apples. Here we're multiplying, and our bases are the same. So we add our exponents. 3r plus 4r plus 7r is just like 3 bananas plus 4 bananas plus 7 bananas is 7 plus 7 is 14. This next one, our bases are not the same, so we can't do anything there. We just leave it just as it is. And for this next one, we have just one base. And if you have one base to the something, that's when you multiply your exponents. X to the 7th, all to the 5th power, is x to the 35th power. We don't have two bases here. We have just one base. And that's when we multiply, if it's to the. Here we have one base to the. So this is when we multiply. We have x to the 6n. So if you just have one base and it's being raised to the power more than one time.